Hey there guys, Erica here from Hive49RC. Hope you all are doing absolutely fantastic today. Welcome back to the water-cooled slash series. Today what we need to do is make a custom coolant tank for this crazy rig right here. That's a problem. There's no rear diff in this thing. I grenaded it, it turns out, and I'm going to solve the problem in a very, very unique way that I don't think anyone has ever done before. So if you want to hear about that, stay tuned till the end of the video. We're going to be replacing this little itty bitty coolant tank that we had before. This is a nitro fuel tank. The hunk of aluminum that I had originally gotten to make a tank out of was this. Yeah, that's kind of too big. Turned out I already had a piece of aluminum, the perfect size, thanks to a viewer. I don't remember your name, but if you are watching, this video has been made possible by you. Thank you so much. I have used your stock for both the tank and the lid in this video. I have used your tooling. Thank you so much. I would show you the piece of stock that I'm going to use. However, it has already been turned into a tank at this point. So with that, let's head over to the computer and take a look at our design. Alright, so I'm in Fusion 360. As you guys know, if you've been paying attention, you know that by now. Alright, covered, cool. So this is the coolant tank I have designed. These larger holes on the front, these are all going to be tapped out for, or drilled out for 1/8 NPT fittings. And I've got more than I need here so that I can add extra stuff. 2 of them are going to be for a fluid level gauge. 2 more are going to be for inlet and outlet, and then I've got 3 extras for other things such as, I don't know, maybe a pressure gauge or a thermocouple, you know, like, you never know, and then an extra on top of that if I need anything else. The lid, I am not going to be machining out the center portion because I want to try and find some sort of cool, toolless filler cap sort of thing. I'm not sure what it's going to be yet. I'm going to look around, see if I can't find anything that looks super trick, but I just put that in there as a placeholder for now. And then of course I'm going to drill the holes and machine this like flange, or the recess I guess. I'm not sure what you want to call that. Technically I guess you would call it a rabbet. Then on the inside here I have notched out this portion to just cut weight as much as I can. The walls are 1/16 of an inch thick along with the bottom. I'm actually going to machine the walls a little bit thicker just because I'm worried about the amount of force that I'm going to need to clamp the tank in the vise. I don't want to crush the walls. I don't think I'm going to, but it better be safe than sorry and add an extra 50 thousandths, which is like very, very little, all things considered. I've left the portion where the NPT fittings are going to be thicker, so that there's more purchase for them to bite on, better, like more amount of space for them to seal. That's pretty much it about it. It's really straightforward, really simple. It's just a box with a flange on it with some holes in it. Not that complicated. It's not rocket science. With that, let's head out in the garage and get started. I know this isn't the first clip of the video, but it is for me, so hey, what's up? Good morning guys, how you doing? It's finally time to get this coolant tank machined. I know I talked about it a bit just before this, talked about the design a bit. Got my stock and my tools here on the workbench. Let's take a look real quick. This is my stock that I'm going to use, stock that a viewer sent in. The lid that I'm going to do today is also stock that a viewer sent in. It's hiding in that box somewhere, I'll pull it out later. I should be able to work my way around this hole. Whatever this dimension is, I think that's supposed to be 3 inches, comes right to the center of the hole. It's about a 1/2 inch hole, and I got to machine a 1/4 inch that way, like to create the flange. So we'll just completely get rid of that hole, which will be perfect. I'm going to take some burrs off on the belt sander real quick because this side's a little dinged up, just so it clamps nice. This is the drill bit for the 1/8 inch NPT ports. This is my long 1/2 inch end mill that I'll be using to get like all the way down inside there. Edge finder, of course. This is my drill for a 3mm tap. It's a number 41 or a 0.096 of an inch. I'll probably be using this guy to rough my stock in, and then I'll probably use this one, which is the corner radius end mill, to get the flange, give it a nice little bit of a radius on the inside corner underneath it. Not that you're ever going to see it, but you know, it looks good. I'm going to get the machine set up and get to work because, you know, that's what we got to do. It's going to be a lot nicer for me this time because I'm not going to be talking to you guys so much. It's just going to be a time lapse because this is not the whole video. There's more than just machining in this video. So it's a little easier on me, more enjoyable, makes things go faster. It would have taken half the time last time if I hadn't been filming everything. But that's how it goes. So, yeah, I'm going to get the machine homed, get it set up, and away I go. Okay, I just got done machining the flange into our tank, and it went well for the most part, but I learned something kind of interesting. Our dimensions ended up really good, but I want to show you what I kind of learned / figured out that's kind of a lesson to me for the future. Okay, so check this out. This is what I got. Turned out really nice. That's our flange. It should work just fine. I adjusted the dimension a little bit from the CAD model that I had to allow for slightly thicker walls because I'm a little concerned about the thickness of them when I go to clamp this thing in the vise to mill out the big inside portion. But what I learned is, well, I guess more me being kind of lazy, was I assumed that this surface was flat enough. Super good enough, some might say. If you look right here, there's a little lip. You see that? That is because this surface is not flat. And I had it clamped up in the vise like this, and I put my edge finder up to this face somewhere in the center here. But if you look, it might be kind of hard to tell on camera, but right here is thicker than in the middle. But what I'm going to do is when I'm done machining out the inside, and once it's all done basically, I'm going to take and flatten the flange all the way around so that my lid will clamp down nice and flat and get a really good seal. I won't take much off, really only enough to just barely skim this center portion because that's where it's thinnest. So like if I go and measure the middle of it here, it's like 0.121. And if I come all the way out here to the edge, I'm at like 0.135, which is quite a lot of discrepancy, but it'll be thick enough for me to tap holes into and for it to still be strong enough to hold the lid on. I just want to flatten it off, and for next time, what I should have done is after I machined this dimension to 3 inches, I should have taken this, clamped it in the vise, and just faced off the top. That would have solved my problems. One other thing to mention real quick is we did not completely get past this bolt hole, which is a bummer. It's okay though. I think I should still be able to get an inner wall that's not broken. I hope, fingers crossed. But to mitigate the deepest part, which is over here, down at the bottom, well, actually I don't know if that's really the deepest part or not, but it looks like it is. This is going to be the port side. which is thicker. I would show you on my piece of wood, but it's currently holding my camera up. But I'm going to make this the port side so it's thicker, and hopefully won't run into an issue there. If I do, that's a problem for later. With that, I am ready to start running my CNC programs. Just going to clean up the vise a little bit because it's a big mess, and get my part clamped up, zeroed out, get the inside of this tank milled out. Oh my god, guys. I have managed to make a bloody diabolical mess. I've got... oh god. I've got coolant back here. Got coolant dripping off of everywhere. Yes, that's a pizza box and it did help. But, oh my god. It's milled out. It's fully milled out. That is insanity. I had the coolant running full blast, and surprisingly, it actually kept the chips flowing out really well. I was expecting to have to halt it in between and clear out chips, but it did a great job. I mean, I had to brush some chips at first, but I mean, that's a lot of mess for such a little thing. That program ran for over an hour. I had to run it at 50% speed because the mill was so long, it was chattering really, really bad. Now, just gotta drill the holes. That's literally it. Drill the holes, and then machine the lid. Dear God, it has been 8 hours straight. Somehow I am running on 3 eggs, a couple handfuls of trail mix, 2 graham crackers, and a yerba. Oh, I don't know how I'm still functioning, but it's done. It is freaking done. I spent way too long futzing with the fitment of the lid onto the tank. Something weird happened with my radii in the corners, and I'm not sure what it was. I thought I had it ironed out in the wooden test run that I did, but clearly I didn't, and so something's a little weird. But But I spent, I don't know, probably 45 minutes with my Dremel, got it cleaned up, added a little like pry point to pop the lid off more easily. Yeah, it'll make sense when I show you. Hang on. Yeah, see, so look, I can get a screwdriver in there, pop, helps lift the lid up. Real nice. There'll be a gasket in there, but as you can see, it is not going to affect where it actually seals, which is great, because the little notch is over here, and it's going to seal more on the inside, which is perfect. You can see where I've been using Sharpie to try and figure out where the hell the lid was rubbing. It was all in the corners in these radii. I don't know why. I'm going to have to look into my program a little closer and figure out why. I thought I had looked it over and it was going to be fine. For some reason it wasn't. But anyway, I got the MPT ports tapped. Those are going to be super sweet with all the fittings on them. Well, at this point, I have like an hour's worth of cleanup to do. But next is going to be to try and figure out how I'm going to mount this thing on the splash. So it's a new day. I've done some thinking. I've slept on it. I've eaten some delicious bakery goods from a local bakery. I've done some thinking about how we're going to mount the tank up on the splash. And it was a little stumping at first considering just how freaking big this tank is. But I think we are going to just sneak it in where I want it. Let's take a look. So what is going to happen is all of our ports with our hose barbs are actually going to fit perfectly just past the shock tower. So all of our hoses will be coming out the front side, which is perfect. I was originally going to have it the other way around, but the bumper would severely get in the way of that. We're still going to have to modify the bumper to make this work, but my original thinking was to move the turnbuckles from the back side to the front side of the shock tower and space the shocks forward a little bit, also moving them to the front side of the caster block. But I don't think I'm going to need to because the differential case provides enough interference that I can only push the tank forward so far. So at best, I'm probably going to sand down these fins a little bit, maybe put a small chamfer on this front corner of the tank just to get it as far forward as I possibly can. I was also thinking I would have to notch out the shock towers a little bit, the thickness of a screw head and the limit strap bracket, so that it would be flush with the front or with the back side of the shock tower, just again as forward as possible. But in terms of the rear bumper, what we're going to have to do is remove this angled support and make a new aluminum one that comes straight across and up. So it's going to be an L shape. This is going to be gone, and it should hopefully just barely fit right in there. I know it's hard to tell right now because everything's in the way, but since it's plastic, I should be able to bend it back just enough that I can get another piece of aluminum in there, probably 1/8 inch thick, thread into that, and I think that will be, at least clearance-wise, taken care of. I'm going to get a time-lapse rolling, put some music on for you guys. I'm going to grab what I need, head out in the shop, and get to work. So, quick update here. I pretty much rebuilt the whole suspension in the rear. These are some RPM A-arms that I had laying around because my old ones were cracked out the bottom in some of the holes I wanted to use. I moved the turnbuckle to the back, like I mentioned. The only way to get to that screw in the back is to take the shock tower off, but that's fine. I mean, when do you ever need to take that screw out anyways? Spaced the shocks forward just a little bit, and it clears just barely perfectly. As you can see, with that bevel filed on the tank and the fins cut off of the differential housing, the tank fits in there absolutely gorgeously, clears the rear bumper mount just perfectly. So I'm gonna make up some L brackets here. Got a piece marked out. I clamped up our Milwaukee cordless bandsaw in my vise, and I put a pair of vice grips on the trigger. So all I gotta do, push the button, clamp them down, and away it goes. Janky as anything, but it works. Back inside now, finally done with all my bracketry. I was not very happy with what I came up with originally, but it's growing on me. I've got this little bracket up here at the top, attached to the body mount, which goes with the screws on the lid. This guy down here could have been a little bit better, could have been a little nicer. Like, these ended up having to be slots, which is just annoying to me, even though you can only get so precise with eyeball measurement, you know. These guys turned out nicely. These L brackets to get rid of the diagonal bumper support. There are screws underneath here that you guys can't see, down under there, attached to where the turnbuckle would normally attach to on this side, but since I swapped them to the back, you know, we have space for the bracket now. Countersunk these guys in so that they sit nice and flush. Then to put in the tank, all I have to do is undo these two screws either side of the bumper, flop this down, slot this into place, like so. Put, you know, the two screws in up here and then the two screws in underneath, and flip this back up. And away we go. I've also left the limit straps off for the time being because... Why did I leave the limit straps off? Well, I'll be honest with you, I don't remember why I left the limit straps off, but I assure you it was for a good reason. Probably something to do with the rear diff. Speaking of, let me tell you about that real quick. So what exactly happened with the rear diff? Well, all the gears stayed intact, which is good. But I was messing around with it a couple weeks ago, and I was like spinning the wheels up pretty fast, and I noticed that the rear drive shaft on one side was wobbling really, really bad. What I figured out is that this aftermarket leading edge machining diff cup, the brass insert on this side is completely wallowed out. Look at that. I can just wiggle that all over the place. And that is what was causing my drive shaft to wobble around a bunch. It also managed to chew up the insides a little bit. It's hard for me to show you guys where it chewed up exactly. So basically the wobbling of this spider gear shaft caused some damage to the inside of the diff cup, along with the brass bushing. Now, brass is a great bushing material, however, it only really works if there's oil supplied directly to it. And in this case, there is not. And I mean oil, not like silicone diff oil, but I mean like engine oil or machine oil type oil. So, how am I going to solve this? Well, I came up with the crazy idea to machine out this outer protrusion, or just machine it off to slightly smaller than 10 millimeters inner diameter. And then what I'm going to do is I'm going to shrink fit a needle bearing into that space that has an outer diameter of 10 millimeters. So this bearing here, the inner race of this bearing, will ride on the outer race of the needle bearing, and the needles of the needle bearing will ride on the spider gear shaft. How exactly I'm going to accomplish all that, I'm not entirely sure yet. I've ordered the bearings that I need. I picked up some super small TIG filler rod. This is 0.035 of an inch filler rod, because what I'm going to do is I am going to weld a flange onto one side of the needle bearing. So pretend this is my needle bearing. This is a wrist pin out of, I don't know, something or other. Pretend this is my needle bearing, and I'm going to weld a flange on it. I don't know, let's find something here. Ah, perfect. A lens cap. I'm going to weld a flange to the back of it so that I can take this flange needle bearing, because I spent hours and hours looking. I could not find a needle bearing that was as small as I need it with a flange. And then I'll take this and stick it inside the diff cup so then it can't fall out basically. But it's also going to be a shrink fit. So I will probably bake the diff cup in the oven at maybe 300 degrees. And then I'll stick the bearing in the freezer. So the diff cup will expand, the bearing will shrink, I'll be able to stick them in, and once they normalize, they will then be more or less press fit together. So hopefully that makes sense. I'm really excited to give that a try. I don't know how well it's gonna work. I hope it works. It might not, but I guess if you want to find out if it works or not, you're gonna have to stay tuned till the next video. In terms of the coolant tank, I'm gonna leave it here because this has been kind of a long video to begin with. And also, I don't want to hook anything up because I still need to tear the rear diff back apart. I think it turned out really good. I know it just kind of looks like a big aluminum box, which is literally what it is. But I'm quite happy with it. I think it turned out really good. And this whole rig is... this is just really something else. So if you guys are excited for the next episode, which is probably going to be almost the final episode of the Splash, which is going to be hooking everything up. I've got some thermocouples on their way. We're going to get temperature sensors going on this thing. It is going to be sweet. So, if you guys have enjoyed this video, please do leave a big fat thumbs up. Thank you again so much for watching. If this does happen to be the first video that you have seen by me, make sure you hit that subscribe button. Comment down below too what you think if you're excited for the needle bearing experiment. As always, follow me on Instagram, support me on Patreon, join my Discord server, and become a member as well. That's all I've got to say, guys. Thank you again so much for watching, and I will see you all in the next one.